Hi guys, welcome to DB Talk channel. In this video, we are going to talk about Postgres roles, a schema, and security related to roles and schema. It's not a complete video to cover the entire security aspect of Postgres because Postgres security is pretty wide area, not possible to cover in just one video. So what is a role? The best way to learn Postgres is to refer its database manual at postgresql.org site. It is very comprehensive documentation and it covers every aspect of PostgreSQL. So it is also very easy to understand and also user friendly. It also has examples so that you can execute and observe the behavior in actual environment. So if you refer the manual page of create role, and it explains here in this description, a role is an entity that can own database objects and have database privileges. So basically role is an entity. So role can be considered a user, a group, or both depending on how it is used. And that is maybe a little bit confusing for users, especially users coming from other database platforms. A role can be considered as a user and also a group or both depending on how it is used. So let me explain a role a little bit more. So essentially role manages the permission at the instance level, database instance level. So if we create a role, it is not just visible inside one database. It can be seen by all the databases. But of course, you can restrict a role to access one particular database or objects of that database. So users and roles are the same thing. So you can have a role and role can be a user at one particular time. Depending on the way how you create it, and also the role is a regular group. So I'm in a server, log into the server where Postgres is installed. This is a Postgres version 12, and here we can get the help of create role statement. So before that we need to log into the server, so we can use a command line interface called psql, and you can mention the server, you can mention the username here. So that username is basically, user is essentially a role, right? Both are same. So user, you can specify the username here. I'm going to specify Postgres. So Postgres is a special user, which is a super user. We are the highest level of the user permissions. So Postgres user can do anything. This is a built-in user. When you install Postgres, this user automatically comes. So if you log into the Postgres using this user, and we are in the Postgres server right now, and then we can get the help page of create role, and you can see here a create role is basically define a new database role, right? And let's get the help of create user, that is to create the user. It is also define a new database role. So basically that tells us essentially the user and roles are the same thing. The difference is user has the privilege to log into the database like we did here, Postgres user, but a typical role cannot log into the server. Let's consider this example. So we have a role, assume that role is sales. And of course that role has no login privilege, meaning you cannot log into the database instance by using sales as a user, because it's not a user, it's a role. And there's a user, there are two users actually, user A and user B. So assume user A and user B are part of the sales group, right? So the structure such as this makes it very easy to ensure that all sales will have the same permissions, right? So we can grant relevant permission to sales group. So whoever the users underneath, sales group will basically inherit by default all the permissions granted to the sales group. So while ensuring their individual activity is operated and logged under their separate identities, because user A and user B can logged into the system because they are users. User is again a role, but it has a login privilege, whereas typical role does not have login privilege. So let's see how we create this scenario in actual Postgres instance. I'm in the same Postgres instance, so I'm going to create a role called sales. So we have command called create role and sales. And of course here we can specify a switch called no login. But as you can remember, role, when you say create role, that role by default does not have login privilege. So it doesn't matter whether you specify this no login switch or even without that, it will create sales role, right? Sales roles has been created now. Then we'll create user, create user. Our example is user A. Now when you say create user by default has login privilege. So you don't have to specify with login clause here, because it by default has the login privilege, the create user command. So we can use create user A, which will create the user A. So there's another way of creating user. So let's create that user B with the new way. Create role user B. Now we use create role statement to create a user B. Now remember, role by default does not have login privilege. So if you create a user like this, you have to specify with login. Then this command is essentially the same command like create user, right? It's a two different way of creating users. Now user A has been created and user B also has been created. So you can verify role and the users that we just created in Postgres. There's a metadata command called du, and you can see the built-in user Postgres is a super user. It's a very high level user which can do anything. And there's a sales role, because everything is role, sales role, and it says cannot login. Yes, that's what we wanted. Sales is a typical role. And this is my own user. And user A we created, so it has by default login privilege. It doesn't mention here. And user B also a user. Now we try to log in this to database instance by using these users. We'll exit from here and we'll use PSQL -u, and let's use sales for just for a testing purpose whether we can log in. Yeah, so it clearly says role sales is not permitted to log in because it's a typical role. It's not a user. And we'll use user A to log in. Right. So now it gives a different error. It says database user A does not exist. So remember, when you specify PSQL command line utility to log in to database instance, you also need to specify the database. By default, it takes Postgres as the by default, it uses the same user as the database. Also, it's looking for the same database with the username user A. But since there's no database called user A, it says database user does not exist. So what you can do is you can specify -d Postgres, or even if you omit -d, it will just refer as a database. So now we are logging into database instance as user A and connecting to database Postgres, and it worked. And we'll also use user B to connect. user B. Yes, we are able to connect. So let's use user A to connect to Postgres database again. User A and database Postgres. So user is able to log into Postgres database, but we have not granted any database level permission to user A or user B in that matter. So we just created the users only. So somehow it has the connect privilege to any database. Even if you have a different database in the same server, user A or user B should be able to connect to that database. So let's try to create a database called test from this user A. So it says user A does not have privilege to create the database. Yeah, that's understandable because we have not granted any create database privilege. So let's exit for the moment and we'll try to log in as Postgres user. Which is the super user, and we'll try to create the database test. Create database. Database is created, and we'll quit from that, and we'll try again user A to connect to that user A here, and then connect into the test database we just created. Right, as expected, user A has privilege to connect to the database. Even we have not granted explicitly to connect privilege to this database. The question is now, nobody has explicitly assigned any connect permission to the user A role, right? Or user A or user B. So where do those permissions actually come from? So there's this thing called public, which is similar to the Unix world, right? So if somebody is part of the public group, there are certain things that public can do. So connect is one of the things that anybody can do. So if everybody is part of public, those people can do, or those users can do everything that public can do, right? So the main thing is that public is not a role, so that you cannot drop or rename. So it is just like everybody in Postgres terms. So, but we can definitely make sure that not everybody can connect to any database at any time. So we can basically revoke connect permissions from users, right? So let's see how we can do it. So we also connect. Now we'll exit from here and we'll connect using the Postgres user, super admin user, and we can issue revoke all on database test from public. So we just revoke the connect permission to database test from public, right? So we'll exit again and we'll try to log in again by using user A to connect to test database. Now you can see the permission denied for database test. User does not have connect privilege. So now we have revoked the connect privilege to test database from the public. So now user A or user B cannot log into test database. You have seen that. Now we want to grant connect permission again to user A and user B explicitly to test database. How can we do that? So remember, we have created a sales group. So user A and user B supposed to be part of the sales group, but we haven't granted yet, or we haven't make user A or B members of sales group. So now let's do that. So I'm going to log into Postgres as sysadmin, super user basically, and I'm going to grant sales to user A as well as user B. So now user both A and user B are part of sales group. Now what we can do is we can grant connect on database test to that sales group. Right. Now what you can do is now try to log in with user A to test database. Earlier it was denied. Now we have explicitly granted connect permission to sales group. Now user A and user B are part of sales group. Now user A and user B can connect to test database. Now you should be able to see now the advantage of the generic role. So whenever new user comes, we don't have to grant explicitly any permission, but we have already granted the required permission for the sales group, so that whoever part of that sales group will basically inherit that permissions. So the advantage of role mechanism is that. So let's focus on schema level permissions for a moment. So let's try to log in again for to the test database using user A. I'm logged in, and there we can try to run certain commands like create database test2. So it says permission denied to create the database for this user, and create schema again test, permission denied, and maybe create user xy, permission denied. So basically the user cannot create a database, user cannot create a schema, user cannot create a user. Let's try to create a table. Tab 1, very simple table with one column. Yep, user is able to create the table, but not any other objects like databases, schemas, users. So what's going on? So by default, the public is allowed to work with the public schema. So there is a public schema on every database. We will come to what is schema later. And this will potentially spam the public schema because anybody can create objects like tables and other objects within this public schema. So therefore it is a very valid reason to revoke permissions from public, so that users cannot create tables like this without explicitly granting permissions for them. So as a best practice, let's revoke all permissions on public schema from public. So in order to do that, you need to log into the server as super user. And then we need to change the database to test, because that's the database we are going to revoke permissions from public. Revoke all means all permissions on schema public. From whom? Again from public. Remember, public is not a role, by the way. Okay, sorry, I misspelled public. Done. From now onwards, nobody can put things into your public schema without the correct permissions anymore. Let's test that again. Let's exit from super user, and I'm going to log in as user A to test database. And user A earlier had permissions to create tables. Now let's try to create the table, maybe table 2, again simple table. Now it says no schema has been selected to create table, because by default, if you don't specify a schema, it will take public as the schema. Now it cannot create a table on public because we have revoked the permission to create any objects on public schema from public. So that is, this create table statement is failing now for anybody on this test database, which is basically a good practice. So let's try to understand why that create table statement failed for user A. So we know that all permissions has been revoked from public schema for the public. So, but how Postgres knows in which schema the table has to be created? So for that, there's something called search path in Postgres. So there basically it says in search path, first search for the schema which is similar name as the user, logged in user, in this case user A. So there's no such schema called user A. And then next search on public. So that's how it basically Postgres search where to put this object. But let's create a table now for the same user. So at this time we are going to specify the schema explicitly. Public table 2 id int. Now remember, this time the error message is different. The permission denied for a schema public, because earlier it says the public, we haven't explicitly specified the schema. So but now we have specified the schema as public, but again it failed because it is obvious, because it's supposed to be failed because all the permissions has been revoked from this public schema. So let's try to understand what is a schema now. So schema is a logical container, so which in turn you can create tables on it, and it can contain data types, it can contain functions, etc. And there are some very valid reasons why you want to create a separate schema, because it's a great way to organize database objects into logical groups to make them more manageable. Like all the sales related objects you can create under sales schema. So all the orders related tables and other types of objects can create under orders schema, something like that. And also if you want to run a third-party applications, that third-party applications objects or everything can be put under separate schema. So that's why you need to have separate schemas, and you probably want to get use of that schema concept. So by default, any database has public schema. So if you don't specify anything, it will create under public schema. So let's talk about more on schema level permissions now. So remember, we created a table called tab1 with user A logged in. So let's try to in this tab, actually I have logged in as user A. Okay, let's check the current user here. Yeah, current user is user A. and there's a table called tab1. I'm going to check the count all from that table now, and it basically says relation tab1 does not exist. So in the same server, in a different tab, I logged in as super user here. Let's check the current user. Current user is Postgres, right? And database is test database, same database. And I'm going to execute the same command here to check the row count of tab1. There you go. So table doesn't have any rows, but it gives you the output. But for the user A, it doesn't give you anything, because so apparently this table is created under public schema. Now user A does not have any privilege on public. Remember, we revoked all the privileges from public that entity for the public schema. So how can we utilize more permissions so that user A can do more things on this public schema? So let's try out that. So as a Postgres user logged in, super user logged in, so I'm going to grant, there's a permission called usage, grant usage permission on schema public now 2. So remember, here we can actually give user A explicitly, so that only user A will get the usage permission, or else we can use the top level group where user A and user B is part of, which is sales group. So I'm going to give sales here. Now grant is given. Now under user A, I'm going to run the same table, count all, and now it works, because user A now sees that table, because actually tab A owner is the user A, but still, since we have revoked permissions from public, it doesn't even give you the count. Now you can see here the table owner is user A, but even the user A is the owner, previously it said table does not exist for the same user. So that's how the Postgres security works. It's a bit of confusing thing, but yeah, that's how it is. So let's dig a bit more into this grant statement of Postgres, which we already used one time. So what we did earlier was grant usage on schema, right? So there are different, the various usage of grant statement. So we probably need to search the one we just used. Actually this one. So grant, and then you have to specify the privilege. In this case, the privilege what we have used earlier was usage, grant usage on schema. We have specifically said public schema to sales roles. That's what we did. So in addition to that, you have more commands that you can use. There are more permissions levels that you can grant at schema level. So grant create is one of them, usage is another one, and there are many more. So if you want to see what are the privileges you can use, you can see here the list of privileges. Grant select, grant insert, likewise grant truncate, various things. You can just go through everything, and also grant usage we just executed. So that's how the grant statement works on schema, and you can give a bit more permissions to that schema for users. So right now we have given only the usage schema, but usage schema does not give a lot of permissions, but it can view the table, it can select the rows from table, you can insert data into that table, things like that you can do. But you cannot, for example, you cannot alter the table schema. So let's try out that one. So let's try to rename that table. So in this tab, I logged in as user A, the same window. So I'm going to use alt table, table name tab1, and I'm going to rename to something else, maybe tab table renamed, something like that. So it says permission denied for schema public. Yeah, so basically that's it, because we have granted only usage permission. Now let's let's see how to resolve that. So let's try to, here I logged in as super user, Postgres, so I can execute alt tables here if you want. But rather than doing that, I just wanted to give the alter table permission to that the sales group, so that whoever part of that group can execute the alter table statement. So I'm going to grant create grant create on schema. Our schema is public to sales group, right? So earlier we have granted usage permission. Now I'm going to grant create permission. So create permission essentially gives you alter permissions as well. Grant create on schema public to sales, right? Now let's try to execute the same command under user A. Yeah, so user A should be able to alter the table now, because we have specifically grant create permission to sales group for the public schema. Since this table is in public schema, the user A and also user B should be able to alter that table. Now select count all from table renamed. Yeah, table is there.
So we can talk more about permissions, but I feel that is enough for this short video. So it was a bit more lengthier video than I thought it would. So I'm going to stop here. Hope these small tips would help you to understand Postgres security a bit more. See you in another video. Thanks for watching.